Hello students. So today we are going to complete the left off part of mathematical induction starting with question number 12. In question number 12, the statement P of n is taken as a plus ar plus ar squared so on up to ar power n minus 1, which is equal to a into r power n minus 1 by r minus 1. So first for n equal to 1, we will take p of 1, but first we will take LHS, that is the first term a. In RHS, when you put n as 1, you have a into r power 1 minus 1 by r minus 1. When r minus 1 cancels, RHS is also a. Because LHS and RHS both are equal to a, we can say P of 1 is true. Now assume that for n equal to k, P of k is true. Because P of k is true, left side, a plus ar squared, so on, up to ar power k minus 1. Because n I have to put as k. On the right side also, n I will put it as k. R power k minus 1 by r minus 1. Now, for n equal to k plus 1, I will take p of k plus 1. First, I will start with left hand side. When I start with left hand side, I will have a plus ar plus ar square. First, I will put n as k, so ar power k minus 1. Then, next term will be n, I will put it as here, I'll put n as k plus 1. So, k plus 1 minus 1. And so, the first few terms from p of k, we can write as a into r power k minus 1 by r minus 1. And then the next term is a into r power k. So now we have to simplify this part. I will take r minus 1, the common denominator. So left is a into r power k minus 1 plus, what do we have? ar power k into r minus 1. When you multiply, you will have a into r power k minus a plus a into r power k plus 1 minus a into r power k. So, a into r power k will cancel. This is what we have. When you pull out a common, r power k plus 1 minus 1 by r minus 1 is left. So, now we will take RHS. In RHS, when you put n as k plus 1, a into r power k plus 1 minus 1 by r minus 1. So already we got it directly. So we have LHS equal to RHS means P of k plus 1 is true. And that is why P of n is true for all natural numbers. This is how we have successfully completed question number 12. Now question number 13 is the statement P of n we will take as 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 and so on 1 plus 2n plus 1 by n square, which is equal to n plus 1 whole square. So first for n equal to 1 in P of 1, the left side will be the first term, that is 1 plus 3 by 1, that is 4. Now RHS, when you put n as 1 plus 1 whole square, 2 square is 4. In this way, LHS is equal to RHS. That's why I can say P of 1 is true. Now assume for n equal to K, P of K is also true. Don't do anything, just put it. Left side, when you put n as k, 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9, so on into 1 plus 2k plus 1 by k square equal to RHS. When you put n as k, you will have k plus 1 whole square. Okay. Now, we will take for n equal to k plus 1, P of k plus 1. But we will take only LHS. So, I will write 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9. So on. First, I will put n as k. So, I will have 1 plus 2k plus 1 by k square. Now, into I will put n as k plus 1. So 1 plus 2 into k plus 1 plus 1 by k plus 1 whole square I have. So the first few terms multiplication, you can use P of k and write it as k plus 1 whole square into 1 plus 2k plus 2 plus 1 is 3 by k plus 1 whole square. Or k plus 1 whole square into denominator common is k plus 1 whole square. In the numerator, you will have k plus 1 whole square plus 2k plus 3, which you have to simplify further. And so you can write k plus 1 whole square into denominator is k plus 1 whole square. Numerator k plus 1 whole square, when you expand, you will have k square plus 2k plus 1, then 2k plus 3. I can cancel k plus 1 whole square. So left is k square plus 4k plus 4, which is nothing but k plus 2 whole square. Coming to right hand side, when you put n as k plus 1, you'll have k plus 1 plus 1 whole square. That is k plus 2 whole square. So you can see left hand side answer, right hand side answers are same. That means P of k plus 1 is true. That means P of n is true for all natural numbers. Very easily we can prove if we are good in simplification. Simplification steps matters a lot. Question number 14 is P of n statement you can write as 1 plus 1 by 1 into 1 plus 1 by 2 into 1 plus 1 by 3, so on, into 1 plus 1 by n equal to n plus 1. For n equal to 1, we will write P of 1. First LHS is the very first term, that is 1 plus 1 by 1, which is 2. RHS, when you write n as 1, directly you will get 2. That means LHS equal to RHS. That means P of 1, we have proved that it is true. Now assume that for n equal to k, P of k is true, blindly you think. Then on left hand side you have 1 plus 1 by 1 into 1 plus 1 by 2 into 1 plus 1 by 3 and so on up to 1 plus 1 by k, because n is k. And RHS you will have k plus 1. So now for n equal to k plus 1, we will take p of k plus 1 but only LHS, which has 1 plus 1 by 1 into 1 plus 1 by 2 into 1 plus 1 by 3. So on. First I will put n as k into next one I will put 1 plus 1 by n as k plus 1. So that the first few terms on multiplication, we can use p of k and write it as k plus 1. After that, we have into 1 by 1 plus k plus 1. 1 by k plus 1. 1 plus 1 by k plus 1. Or I can write this as k plus 1 into denominator, common denominator k plus 1. Numerator k plus 1 plus 1. So that means I have k plus 1 into k plus 2 by k plus 1. Of course, k plus 1 will cancel. You get k plus 2. But on RHS, when you put n as k plus 1, n plus 1. That is k plus 2. You can see LHS and RHS are same. So when LHS and RHS are same, you can say P of k plus 1 is true. That means P of n is true for all natural numbers. So this also completed. We can go to question number 15. P of n statement is 1 square plus 3 square plus 5 square, so on, up to 2n minus 1 whole square equal to n into 2n minus 1 into 2n plus 1 by 3. So first for n equal to 1, we will take p of 1. Left hand side you will take only the first term 1 square, that is 1. Right hand side you will put n as 1, 2 minus 1 into 2 plus 1 by 3. That will be 3 by 3, that will be 1. Because both left hand side and right hand side you got same answer 1. You can say that P of 1 is true. That means whatever formula is given, if n equal to 1, it is true. But I can't prove for n equal to 2 it is true or not. For n equal to 3 it is true or not. N equal to 4 it is true or not. N equal to 5, 6, 7, 8. Like that I can't prove. That's why what I am doing is assume that for any n equal to k, P of k is true. Take n as k, any number k. Like n can be 1 also. So we are assuming for n equal to 1, P of 1 is true. We need not assume. Already we have proved. Say for instance, k I will take as 1. That is what I am doing. So for n equal to k, P of k is true means we will take left hand side 1 square plus 3 square plus 5 square up to n is k, so 2k minus 1 whole square. Right hand side is k into 2k minus 1 into 2k plus 1 by 3. So both left hand side and right hand side I have put n as k. I am thinking that n equal to k is P of k is true. That means, for instance, for n equal to 1, P of 1 is true. Now, after that, n equal to k plus 1, 1 extra. Here n equal to k, here n equal to k plus 1, 1 extra. So, we will take P of k plus 1, we will prove. We will take left hand side and I'll take 1 square plus 3 square plus 5 square. First I will take up to n equal to k, 2k minus 1 whole square. After that I have to take one extra, that is n is k plus 1. So 2 into k plus 1 minus 1 whole square. Now, in order to write these first few terms, I can use this P of k which I have assumed. So, I am using P of k. For P of k plus 1, I am using P of k. Remember, when we are taking P of k plus 1 proof, P of k has lot of importance. So, I will use P of k and write as k into 2k minus 1 into 2k plus 1 by 3. And after that I have 2k, 2 minus 1 is 1 whole square. So P of k plus 1 I am proving. Directly I am not thinking anything. So when I take common denominator 3, I have k into 2k minus 1 into 2k plus 1 plus 3 into 2k plus 1 whole square. I will take 2k plus 1 common. Left is k into 2k minus 1 plus 3 into 1 more 2k plus 1 is left by 3. That means 2k plus 1 will be outside. Inside I have 2k square minus k plus 6k plus 3 by 3. That means, how to simplify this? I will write 2k plus 1. 1 second, it is going down. So I will write 2k plus 1 into 2k square plus 5k plus 3 by 3. Now writing 2k plus 1, I'll factorize this 2k plus 5, 2k square plus 5k plus 3. How to factorize it? One factor will be k plus 1, the other factor will be 2k plus 3. Denominator 3. This is what I got. But till now we did not take RHS. In RHS, when I put n as k plus 1, what will I have? K plus 1 into 2 into k plus 1 minus 1 into 2 into k plus 1 plus 1 by 3. And that will be k plus 1 into 2k plus 2 minus 1 into 2k plus 2 plus 1 by 3. That is nothing but k plus 1 into 2k plus 1 into 2k plus 3 by 3. So here also we got LHS equal to RHS. That implies P of k plus 1 is true. So what did we get? We got P of 1 is true. Then we assumed if P of k is true, the next P of k plus 1 is also true. This is what we got. That means if P of 1 is true, the next one P of 2 is true. Next. If P of 2 is true, the next one P of 3 is true. If P of 3 is true, the next one will be true. Like that it will go in a chain. We need not prove for each and every one, but it is understood. That's why we can say P of n is true for all natural numbers. Instead of proving for all natural numbers, we are using principle of finite mathematical induction. by principle of finite mathematical induction. Short form. Okay, next we can go to question number 16. Still we are in question number 16. As I told you, we have to go up to question number 24. In this class, we have to finish it. The statement P of n is 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10, so on, 1 by 3n minus 2 into 3n plus 1 equal to n by 3n plus 1. First, we will take for n equal to 1. We will take P of 1. First, left hand side means only the first term. 1 by 1 into 4. That is 1 by 4. Right hand side also, I will put n equal to 1. 1 by 3 plus 1, I got same answer 1 by 4. That means P of 1 is true because LHS equal to RHS. Now, instead of proving for n equal to 2, 3 and all, I will assume for any n equal to k, P of k is true, like P of 1 is true. Then I can take left side 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10, so on, 1 by, write n as k, 3k minus 2 into 3k plus 1 equal to, right side also put n as k by 3k plus 1. Now for n equal to k plus 1, next number of k, we will prove P of k plus 1 is true. That means we are showing if P of k is true, using this, we can prove that P of k plus 1 is true. For left hand side, you will take 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 and so on. We first put n as k, 3k minus 2 into 3k plus 1. After that, next term, I will write k plus 1. 3 into k plus 1 minus 2. And then 3 into k plus 1 plus 1. So that the first two terms you can use from P of k and write it as k by 3k plus 1. And then what you will have, plus 1 by 3k plus 3 minus 2 is 1 into 3k, 3 plus 1 is 4. So I have to take common denominator. The common denominator will be 3k plus 1 into 3k plus 4. So numerator will be k into 3k plus 4 plus 1. So that I can take 3k square plus 4k plus 1 by 3k plus 1 into 3k plus 4. I will factorize the numerator by writing it as k plus 1 into 3k plus 1 by 3k plus 1 into 3k plus 4. 3k plus 1 cancels. You will have k plus 1 by 3k plus 4. The same thing if we find on RHS by putting n as k plus 1 by 3 into k plus 1 plus 1. So you have 3k plus 3 plus 1. So same answer we got. LHS answer and RHS answer. That means P of k plus 1 is true. By the same way, P of n is true by principle of mathematical induction for all natural numbers, for all n belonging to set of natural numbers. You can write that. Okay, now we will take question number 17. The statement P of n is 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9, so on, 1 by 2n plus 1 into 2n plus 3 equal to n by 3 into 2n plus 3. First we will take for n equal to 1, P of 1. Left hand side you will take the first term 1 by 3 into 5, that is 1 by 50. Right hand side you will put n as k plus 1. Sorry. Now n is not k plus 1, n is 1. Right hand side you will put n as 1, 3 into 2 plus 3, that is 1 by 15. Because left side is equal to right side, you can say that P of 1 is true. Now, instead of checking for P of 2, P of 3, we will assume that for n equal to any number k, P of k is true. That means left side 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9, so on, 1 by 2n plus 1 into 2n plus 3. I will write n as k because I'm thinking n is any number k, it is true. On right side also I will put n as k, 3 into 2k plus 3. Now after k, we have k plus 1. So for n equal to k plus 1, we will prove P of k plus 1 by starting with left hand side, that is 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9. Then I will put n as k, so I'll have 1 by 2, 2k plus 1 into 2k plus 3 plus, now I will put n as k plus 1. 2 into k plus 1 plus 1 into 2 into k plus 1 plus 3. So that the first few terms I can take help of P of k and write it as k by 3 into 2k plus 3. And then the next term is 1 by 2k plus 3 into 2k plus 5. This is what I have. Now I can take LCM for this one, or common denominator. So common denominator I will write 3 into 2k plus 3 into 2k plus 5. This is what I have written. So numerator will be k into 2k plus 5 plus 3. So that I will write 2k square plus 5k plus 3 by 3 into 2k plus 3 into 2k plus 5. Numerator, I will factorize it as k plus 1 into 2k plus 3 by 3 into 2k plus 3 into 2k plus 5. So 2k plus 3 will cancel. Left is k plus 1 by 3 into 2k plus 5. This is left side. Right side also we will put n as k plus 1. So you will have k plus 1 by 3 into 2 into k plus 1 plus 3. That is k plus 1 by 3 into 2k plus 5. Both left side and right side you got the same answer. That means P of k plus 1 is true. So if for k it is true, for k plus 1 it will be true. For 1 we have proved that it is true, so for 2 it will be true. If for 2 it is true, for 3 it will be true. If 3 is true, 4 will be true. Like that. And so you can say P of n is true for all natural numbers by principle of mathematical induction. Every time you have to write this by principle of finite mathematical induction. That's a must. You can't skip it. Okay, now we will go to question number 18. In question number 18, the statement P of n is 1 plus 2 plus 3 up to n is less than 1 by 8 into 2n plus 1 whole square. First, for n equal to 1, we will take P of 1. That is only the first term 1. So this is LHS. RHS, what we have, put n as 1, 1 by 8 into 2 plus 1, 3 square. That is, we are having 8. What is 9 by 8? 8 ones 8. 1. Point. Now you will have 0. Again you will have 8 ones 8. 2. Something like 1.12. So you can see LHS is less than RHS, which is true. Now for n equal to k, we can assume that P of k is true. When you take for n equal to k plus 1, that you have to put. So at present, we have taken n equal to k to be true. That means blindly you can put n equal to k, left side, 1 plus 2 plus 3 plus up to k, and say that it is less than 1 by 8 into 2k plus 1 whole square. Now we will prove for n equal to k plus 1 by taking P of k plus 1. So we will take left hand side, that is 1 plus 2 plus 3 plus up to n. But n, first we will put k, next term we will put k plus 1. So that these few terms you can use for P of k and write it as 1 by 8 into 2k plus 1 whole square. And then we have k plus 1 also. So now how we can write this? One by 8 into 2k plus 1 whole square plus k plus 1. How to get the RHS? Because when you write this, when you are using P of k, what happens when you use P of k? This entire thing is less than 1 by 8 into 2k plus 1 whole square. So I will write less than 1 by 8 into 2k plus 1 whole square. Then I will write plus k plus 1. Or here I can write 1 by 8 into 4k square plus 4k plus 1 plus k plus 1. Or I can write 1 by 8 into 4k square. I will write on the new page. I will take LCM as 8. That's all. Or I have denominator. It's going cross. I will take common denominator 8. So what I will have? 2k plus 1 whole square plus 8 into k plus 1. Or I can write 4k square plus 4k plus 1 plus 8k plus 1 by 8. Or 4k square plus 12k plus 2 by 8. I won't get 2. Here 8. So I will get 9. Yes, 9 is correct. Now I can factorize this. 4k square plus 12k plus 9. How will I factorize? 2k plus 3 into 2k plus 3 by 8. So I have less than 1 by 8 into 2k plus 3 whole square. But on RHS, when you put n as k plus 1, what you will have? 1 by 8 into 2 into k plus 1 plus 1 whole square. That is 1 by 8 into 2k plus 3 whole square. You got LHS less than RHS. That means P of k plus 1 is true. So, for all natural numbers, P of k plus 1, that is P of n for all natural numbers. P of n will be true forever. Next, we will go to question number 19. Oh, we have done a lot of terms. Yes, but now we have to go to 19. The statement P of n is n into n plus 1 into n plus 5 is multiple of 3. That means it is 3 into m something. So first for n equal to 1, When we take P of 1, we will take LHS, that is 1 into 1 plus 1 into 1 plus 5. That is 2 into 6 or 12. And we can say this is easily multiple of 3. So P of 1 is multiple of 3 means P of 1 is true. Now assume that for n equal to k, P of k is true. That means blindly you will write left hand side equal to right hand side by putting n as k. That means k into k plus 1 into k plus 5 is multiple of 3. That is what I have written. Now for n equal to k plus 1, we have to take p of k plus 1, but we will take left hand side. Put n as k plus 1, again k plus 1 plus 1, then n is k plus 1 plus 5. Or what we have is k plus 1 into k plus 2 into k plus 6. This we have to prove that it is multiple of 3. Till now, we did not prove anything. Okay, how will I use P of k? I have to use P of k. No other way. But how to use P of k here? You have to multiply in such a way that we can use P of k. So on the next page, what I will write is, I will write k plus 1 into k plus 2 into k plus 5 plus 1 instead of writing k plus 6. So that first I will distribute this one to this. I'll have k plus 1 into k plus 2 into k plus 5. And then when I distribute the other one, I will have plus k plus 1. I will erase this extra mark. When I distribute the other one, I have k plus 1 into k plus 2. This is how I am distributing. Now further I will distribute. How to distribute further? I have to distribute this part. Conveniently, I have to distribute. So, I will write this as k plus 2 into k plus 1 into k plus 5. And this I will keep same, k plus 1 into k plus 2. First, I will distribute k with these. That means I have k into k plus 1 into k plus 5. Then I will distribute 2 with these two. So I have 2 into k plus 1 into k plus 5. And then the last term I have is k plus 1 into k plus 2. This is all I have. So if you try to use P of k now, k into k plus 1 into k plus 5 is 3m. So k into k plus 1 into k plus 5, I can write it as multiple of 3. Then from these two, I can take k plus 1 common. So what I have? 2 into k plus 5 plus k plus 2. This is left. So 3m plus k plus 1 into 2k plus 10 plus k plus 2. Or 3m plus k plus 1 into 3k plus 12. So what I will do is I'll take 3 common. M plus k plus 1 into k plus 4. This is what I have. That means it is a multiple of 3. For k plus 1 also we got multiple of 3. So I can say P of k plus 1 is true. That implies by principle of finite mathematical induction, P of n is also true for all natural numbers. We can go to the next one. Question number 20. The statement P of n in question number 20 is 10 power 2n minus 1 plus 1 is divisible by 11. That means it is the multiple of 11. That is what we are saying. For n equal to 1, we will consider P of 1, but first left hand side. That is 10 power 2 into 1 minus 1 plus 1. So 10 power 1 plus 1, that is 11. It is multiple of 11. That means P of 1 is true. Next, we will assume for n equal to k, P of k is true. That means blindly you can put in LHS n power to 10 power 2k minus 1 plus 1, n as k. And then RHS I can write it is multiple of 11 directly. So that for n equal to k plus 1 you can use it. When we consider P of k plus 1, I will take LHS, that is 10 power 2 into k plus 1 minus 1 plus 1. If you simplify this LHS further, you can write it as 10 power 2k plus 2 minus 1 plus 1. Or you can write 10 power 2k plus 1 plus 1. Now, how to use P of k? If you have 10 power 2k minus 1, you can write it as 11m minus 1. So what I will do? 10 power 2k minus 1 plus 2 I will take. So that I can take 10 power 2k minus 1 separately, 10 square separately and plus 1. And then I will write 10 power 2k minus 1. From n equal to k, I can write it as 11m minus n. So 10 power 2k minus 1, I will write 11m minus 1 into 10 square plus 1. This is what we got. So when I distribute, 10 square is multiplied to 11m minus 10 square plus 1. So 10 square into 11m minus 100 plus 1. That means 10 square into 11m minus 99. I can take 11 common. So you will have 10 square m minus 9. When I pull out 11. So here I can say it is multiple of 11. So I can say P of k plus 1 is true. P of n is also true by principle of mathematical induction for all natural numbers. We can go to 21. Let us take the statement P of n as x power 2n minus y power 2n is divisible by x plus y. That means it is multiple of x plus y. Okay. For n equal to 1, when we take p of 1, left hand side we have x square minus y square, which I can write as x minus 1 into x plus y. X minus y into x plus y. That means x plus y into x minus y. That is, it is multiple of x plus y. So we got this as equal to RHS, and we can say because LHS is equal to RHS, P of 1 is true. Next, we will assume that for n equal to k, P of k is true. That means directly x power 2k minus y power 2k. It is divisible by x plus y. I am writing directly. Lastly, for k equal to 1, that is P of k plus 1 you will take. Then left hand side you have x power 2 into k plus 1 minus y power 2 into k plus 1. But how to show that it is divisible by x plus y? That's the question. So what I will do is x power 2k plus 2 minus y power 2k plus 2 we have. Or I can write x power 2k into x square minus y power 2k into y square. Now how will I write x power 2k? From P of k, x power 2k can be written as x plus y times m plus y power 2k. So I will write x plus y times m, x power 2k. I can write x plus y power m plus y power 2k. So what will I write? X plus y into m, then minus y power 2k will become plus y power 2k into x square minus y power 2k into y square. So I can write x plus y into x square into m plus x square into y power 2k minus y square into y power 2k. So this part, when I take y power 2k out, you will have x square minus y square. The second part I am taking. The first part I will write same, x square plus x plus y into. Now I can write x square into x plus y into m plus x square minus y square. I will write x plus y into x minus y into y power 2k. If I pull out x plus y common, then I will have mx square plus x minus y into y power 2k. That means it is some multiple of x plus y, which we have proved. That's why p of k plus 1 is true. And so, by principle of finite mathematical induction, p of x is true, or p of n is true for all natural numbers. I think we can do only question number 22, 23 and 24. When we do MSET at that time, we will complete. Question number 22 is P of n. The statement is given as 3 power 2n plus 2 minus 8n minus n is divisible by 8. That means this is multiple of 8. So if you take for n equal to 1, P of 1, then you will have left hand side equal to 3 power n is 1. 2 plus 2 minus 8 minus 9. 3 power 4 is 81 minus 8 minus 9. 81 minus 8 is 73. 73 minus 9 is 64, which is multiple of 8. So we have shown that P of 1 is true. Now assume that for n equal to k, P of k is true. That means I can say when I put n as k, 3 power 2k plus 2 minus 8k minus n, 9. In place of n, I am putting k. It is divisible by 8. It is a multiple of 8. I am writing direct. But I will prove for n equal to k plus 1. I will take left hand side 3 power 2 into k plus 1 plus 2 minus 8 into k plus 1 minus 9. This we have to prove that it is divisible by 8. So this LHS only I will simplify 3 power 2k plus 2 and 3 power 2 separately. Minus 8k minus 8 separately and then minus 9. Now how will I use P of k here? 3 power 2k plus 2 I can write 8m plus 8k plus 9. So this 3 power 2k plus 2 I will write as 8m plus 8k plus 9 into 9 minus 8k minus 8 minus 9. So I can write 8m is multiplied to 9 then 8k is multiplied to 9, so 72k plus 81 minus 8k minus 8 minus 9. So that is I will have 8m into 9, 72k minus 8k, 64k 81 minus 8, 73. 73 minus 9, 64. I will pull out 8. 9m plus 8k plus 8. It is multiple of 8. Multiple. So that means P of k plus 1 is also true. It is also multiple of 8. So for all natural numbers, P of n is true by principle of finite mathematical induction. Two more problems are there that we will finish it in the next class. Meanwhile, practice all the sums. We will end the class here.